So this was our motor class that we did yesterday, and I kept saying this is the one piece, this is past service, that I don't like. And the reason I don't like it is that we know that if you know that the motor is past service, that means that there's somehow more hours on the motor than there should be. So there's some sense of more or greater than, and I see a less than sign there. Okay? And I really want the same sense of how people think about it. So the question is how would you change that piece of code so that there's a greater than sign there and it's really obvious exactly what we intended?
If hours of service greater than maximum hours.
So this should, let's just get rid of this entirely and let's just say what we mean. If hours of service is greater than maximum hours before service, then we're past service due. Okay? So we get back to this point that you can say things in lots of different ways in code, but what you're trying to do is say it really in the way that you think it, the most natural and obvious way that it comes across. And so now there's no way that somebody's going to come along and change that less than sign to a greater than sign, right? The risk of this one is that somebody who's in a hurry is going to look at this thing and go, oh, they didn't mean less than, because, you know, if it's past due, that always means greater than. Just let me go change that less than sign to a greater than sign, which would break it. And if you didn't have the unit tests, it would just introduce a bug. Okay? So the closer you can get to saying what you mean, the more likely you are that people are just going to end up leaving the right thing in the code, and it will just work as promised. And just let me put that back the way it was. So this is probably the better way and more obvious way of saying it. Okay, fix that, so now I can sleep tonight. Let's go back and look in our driver program at what we were doing with lists. Just to review, we said, here's how you make a new list in Java. The only thing that's a little weird is the right-hand side says ArrayList rather than list. And so that's just the specific kind of list that we're using. Okay? So it's basically always going to look like that. If you had a list of students, you would just replace the word motor with student and change the name of the variable, and off you go. Okay? The angle brackets are a restriction. A list can hold any type of thing. So those things say I want a list that only holds motors. So usually when I read it, I'll say a list of just motors or only motors. Okay? So we added a bunch of motors onto the list. Just to show you, a string happens to be a kind of object, so conceivably we could try to add a string onto a list, or a cat or a dog or whatever it happened to be. And now all of a sudden the compiler is giving me an error, and it's saying, you can't do that. You can't put a string into something that's only supposed to have motors in it. If you were to take these angle brackets off and just say, I want a general list, then all of a sudden notice that even though it's got some warnings, it would allow you to add a string to a list of motors, and it wouldn't give you a syntax error. Okay? So some languages will allow that. Okay? And some languages think that that's a good thing. The approach that Java has is to say, I want to be really specific all the time, because the more specific I can be about things, the less opportunity there is for people to make weird sorts of errors. Okay? So Java won't allow that if you put in the proper declaration. Okay, so we added a bunch of motors, and we said, here's a loop that goes through all of the motors and prints out their serial number. Okay, so notice I've stopped reading a lot of the weird syntax and just said, oh, a loop means go through all of them, and what are we going to do? Oh, we're going to print out some information. This, if I were to actually read out the details of the syntax, I'd say for each motor, some motor in all motors. Okay, so that's probably the best way to read it if you have to. Okay, so go through all of the motors and print them out. The nice thing we said about that for each is that there's no doubt that you get all of them, because the loop only goes through all of them on purpose. Another alternative we saw was that you could do a counted loop, and so counted loops in most programming languages that have some sort of history from C all look this way. You start some variable at 0, it goes for less than maximum by 1. Okay? That particular syntax, when you see a counted loop, also means go through all of them. Okay? So this is another one where even if you write a counted loop, chances are pretty good you almost always type in exactly that. And so 95% of the time when somebody says write a loop, if you just write that, you're probably correct. Okay? Don't have to worry about much of anything else. The variable here is almost always I, and that's just an old tradition that dates back to the 1970s, but I is as good as anything else. And most people will write it with an I. So for as much as the variable sum motor is going to change for every one of the things that you've got inside this loop, the variable I is the thing that's going to change within that loop all the time. So the I there is the thing that keeps getting incremented. Okay? And notice the interesting thing about using Java is that going and getting information like this is eventually a multi-stage process. So the first thing that we've got to do is talk to the list and say, hey, give me a motor back. Okay, step number 1. And now that the list has given you a motor back, the next thing to do is talk to the motor that you got and ask it for some information. Okay, so we're working down the hierarchy. The list holds motors, so we'll go get a motor off the list. Now we've got to talk to the motor and get some information and then print it out. Okay, so there's the sort of the two standard loop styles that you would see. We generally prefer the for each because there's less opportunity for error and it's just a lot easier to write. This one, the problem is getting the first and the last right. The common mistake that people make is to put in an equals sign there or to start the thing at 1. Both of those are problems. Okay? So my rule is if I see anything else but that for syntax, then chances are pretty good it's a bug. Okay, so either one of those will print out all of the motors. So what's next on my list here? Let's just go back and look. Okay. Let's try this. If we go back and look at our original motors, I've still got that variable C motor lying around. If I go just before this loop and I say C motor dot add hours of service some number, and then I actually print out hours of service, yeah, that's Eclipse being helpful. Sure, that one won't make any difference. So I add 300 hours of service to C motor. What about the motors on the list? Have they changed or not changed?
C motor should have.
Okay, so let's just leave this out for a second and run it. And the values that are produced are 6, 9, and 4, okay, for hours of service. If I put that thing back in to change the hours of service, am I going to see the 4 change to a 300?
304.
Or 304, whatever it happens to be. How many votes for no? So everybody's saying yes, it's going to change. certainly hope so. These are good exam questions. Other than that, it's 604. Oh, gee, that's so interesting.
Sorry, you got it duplicated for your pictures.
Oh. Oops. Do it again. There we go. Does that make sense?
Yes,
Why does it make sense?
because it's the same instance. Just because you put it in a list doesn't mean it's a different entity.
It's the same thing, it just happens to be on a list. The easiest way that you can think of these is, think of them as being somebody's phone number. Okay? So it's literally like the list is an address book, and you've got a scrap piece of paper that has somebody's phone number on it, and you take that phone number and you dump it into your address book. Okay? So if you call them with the phone number that's on the scrap piece of paper and tell them to do something, it's just the same as if you dug the number out of the address book and asked them to do something. It's still exactly the same person. Okay? Well, so what about this then? Suppose I do, I'll leave that one in there. Let's hit them with a bus. Suppose I do that. What happens now? Does C motor disappear?
No, it was just all the values will be null.
What's going to get printed out? Another good exam question.
No.
Run it again and see. Same thing.
If the add hours of services where it's throwing 300 and then it's just, oh, yeah, it's 200 and
So if we go back to this address book concept again, right? C motor is just a piece of paper that has a number on it. We're taking that number, that phone number, and we've transferred it into the address book. Okay? So if I take the piece of paper and I phone somebody and say do something, and then I crumple up that piece of paper and throw it away, which is throwing away C motor, setting it to null, the question is are they still in the address book? And the answer is yes. They're still in the address book. They've got the updated value just like before I did whatever I did. Okay, so they haven't changed. And that's almost exactly what is usually done. Okay, because this thing is actually, you can think of it as coming from a different part of the program, a different moment in time. This might come at the start of the program where somebody in a GUI comes along and they type in the values for a motor. You make a new motor object, you add it on to the list of motors, and then all the stuff in the GUI can be refreshed and you can start all over again because that piece of information is still held on the list. Okay, so we can wipe out that piece of information in the GUI and start all over again and make a new motor and add it to the list. Okay, so you wouldn't normally see this in a piece of code this close together. It would be some different moment in time. But that's quite normal. The list is going to hold on to things. The C was just a temporary thing until we got it onto the list. Once it's there, you can always go get it back from the list. Okay. So that's pretty typical of lists. What else have we got? Suppose that I only want all of the motors that have more than 5 hours of service on them, or I guess I should make it more than 8 hours of service, just so we get some of them. How would I go about printing out just some of the motors?
You have to create a loop to build a new list.
Suppose I just want them printed out for a start. So let's write another loop, something here, so we only greater than, whatever I said, 8 hours service. Suppose I want to do that. How would I go about doing that?
Do a for loop.
Do a, what kind of loop? For loop. For each is probably the easiest one for motor, a motor, in all motors.
And then the if.
It's got to be a different variable.
Check.
If what?
Hours of service.
So
There's a couple of ways of
some
writing
word
this.
dot, yeah.
Is greater than, I said 8. Then print it out. I guess that's going to be that all over again. Like so. That's how you traditionally see it written. But I find that that involves too much thinking. And the other problem with it is that it does too much stuff at once, and it's got sort of the important thing buried where it shouldn't be. Let me try it a different way. I'll do the same thing again with the for each loop. Whatever it happens to be. I'm going to break down the process a little bit, and I'm going to say the first thing that I want to do is get the hours out of X motor. And then I'm going to say and then if I just wanted to print it out, the normal thing to do would be to just do the print hours. So let me steal that one because it's close. Okay, so that would be the normal thing to do. Okay, so what's the reason for not doing that?
We only want ones that have greater than 8.
Less than or equal to.
So if the hours were less than or equal to 8, what would you do?
Return.
Well, careful here.
No, because you can't. Yeah.
Return would get you out of the program. Where would you like to go? You don't want to do this statement.
Back to the top of the loop.
You want to go back up to the top of the loop. So the thing that says go back up to the top of the loop is that. So remember when we wrote methods, we had this idea of we'll use the return statement as an early return to go back in case there's something silly that's not quite right. So this is exactly the same idea, except that we can't use a return there because that would kill the program. So continue has the effect of saying just go back up to the top of the loop and try again. Okay, this one's no good, try again. This one's no good, try again. Eventually you get the one that's right for you. Okay? Which one of those strategies do you like? Don't just say that because you know I like it. Okay? Like I say, traditionally you would see it written the top way. Suppose that in this case you want to see whether or not it's broken. You're not sure what's going on, and you break out the debugger. What's going to happen when you try to use the debugger on that one?
You won't be able to see any of the values.
You won't be able to see this value easily, right? Because it doesn't show up anywhere unless you do a step into and try to see what it is. And the other thing I don't like about it is the thing that you're actually trying to do is buried way inside there, and it's also repeated because you didn't bother making a variable for it. Okay? If you look at this one, you can start out and you can just leave this thing out and write out what you would normally write out. Just do all of them, okay, which is what it would do without that if statement. You get the value of putting this thing into a variable so that the debugger will show you the value. So you're doing basically one step at a time. Oh, okay, I got to go through all of them. For each motor, let me go and retrieve the number of hours. Yeah, it's the step-by-step process in a little bit more detail, but you just write what you would write first. Oh, let me go get the hours, let me print it out. And then you come along afterwards and you can start thinking of restrictions there for why you wouldn't print it out. Okay? Suppose that I add another condition that says that I want only the numbers between, I don't know, 8 and 32. What would you change in this version?
You have to add an and.
You'd have to add an and here, and, what are we going to do here? Oh, we're going to repeat this, aren't we? So let's just repeat that again, because cut and paste is obviously the easiest thing to do there. And that is less than 32, then we'd do it. What would you do in this case?
So add another if. Greater than or equal to 32.
Whatever it happened to be, greater than, or equal, really doesn't matter. We'll fix that later. So notice the difference. Here, when you write this thing, every time you add a restriction, the line is getting longer and longer and longer and more complicated and more unmanageable, and it sort of runs off the page so you can't see it anymore. And you're forcing people to read across the page. In this case, what's happening is you just go, okay, you want another restriction? Oh, that's easy. There's another restriction. And people continue to read down the page. And not only that, if they're uninterested in the restrictions, you can ignore all of that code. And you can just go, oh, it looks like it prints out whatever. Okay? So you can totally ignore the if statements because they're just a restriction. In this case, you sort of have to, you get the feeling that you want to read the if statements so that you can figure out what it's doing because it's in the way of you finding out what the print statement is doing. Okay? It used to be that this was frowned upon. Okay? And my suggestion is this is actually easier for human beings to read. They used to write it this way because that's easier for the compiler to figure out and it generates less assembly language instructions probably. That was the old rule. But in the modern world, this is easier for human beings to understand, and by the time you go look at the actual generated code, if you really cared about cycles, compiler writers are a lot smarter than they used to be now, and it's probably just about as efficient. So it doesn't make all that much difference. So this is probably a better strategy to use because it tends to be just a little bit simpler to understand. And it follows my rule of saying, just do one small step at a time. Don't try to make things complicated by doing lots of steps because that will make them harder to think about and harder to see in the debugger. Okay? It's just, what do I have to do next? What's the simplest thing I have to do next? Okay, this process, by the way, the correct computer science terminology is filtering, because you're filtering out some things and reducing the number of things that you have. Okay, I'm just going to get, well, maybe I'll leave that one in there. Suppose that I wanted add all items more than 20 hours. How about I want to add anything that has more than 20 hours to a list? I want to make a new list of all of the stuff that I have to work on. What would you do?
First you have to create the new list.
First we have to make a new list, so we'll do a list that can only hold motors of needs work. So that's a new array list. You can steal the line up above. I'm just duplicating it or writing it out longhand to try to get you to think about it. A new list that can only hold motors. Then what?
You need a for loop.
Then make another loop that goes through all of the ones that you've got. So that's motor, any motor, in all motors. Go through all of the motors. And that's, oops. There we go. The Pfeiffer trap has been set.
So if it's greater than or equal to 20 hours, continue.
Do the,
Add the motor to the list?
just add more to the list.
Yeah.
Let's just put them all on the list for a start, right? So someplace you're going to have, oh, okay, what I'm going to do, well, you know, it could turn out that all of the motors needed to be on the list, so we'll just add any motor onto the list. That's I'm going to make the most amount of money, rose-colored glasses, I'm a mechanic, and everybody needs their motor fixed. Okay, I'm happy now. Okay, so now people start to take away things, right? So now it becomes, why would they take away things?
Less than or equal to 20 hours.
So if,
Less than 20 hours continue.
First
what are you interested in about the motor?
How many hours?
How many hours? So I would still, even though it seems pretty simple, just always go, what am I interested in now? Oh, I'm interested in how many hours this motor has on it, right? So that's the thing I'm interested in. We'll talk to any motor and we'll just ask it that question. How many hours do you have? And now I know what I need to do. If hours is less than or equal to 20, then go look for another one. This one's fine. Okay, so I'm trying to repeat that process of do the simple thing first and then go back and worry about the restrictions later, rather than getting all caught up in trying to worry about the restrictions and then what do I do with it. Okay, so there's another example, and then if you want, you can go through and you can write a for each that prints out all of them. So for motor, work in, and now it's needs work. So just to give you a different sample of a loop. Something like that. Print out the serial number for all of the motors that need work. Okay, so there we are going through a different list of things. Okay, questions about that?
Do all this belong in the driver?
The driver here is just really a test example of, you know, here's a bunch of different scenarios that you would see. So what I'm really trying to do is give you sample code that you can use for doing your lab 3. Okay, so usually the labs, you'll see that I don't ask you to go magically dig up things off the internet. I'm going to only ask you to do things that I've already shown you how to do. Okay, so there's that one. What else have I got on my list? We did those. We made essentially a sub-list, and we talked about changing. Okay, that's maybe a brief example of some of the stuff we can do with lists. Let's try doing something else with this list. Let's talk about searching for the biggest one. So I want to find the motor that has the most hours on it.
So you need to create a variable.
The worst one.
To create a variable called most hours. No, because if you don't have the variable, then you have nothing to compare what you find in the list.
I don't even have a list for
You have the list of all the motors.
The interesting thing about all of these sorts of problems that they start you out with in computer science is that they're all problems that you learned how to do when you were like 3 years old. And the problem is that, not that you don't know how to do them, but that they just do them in such an innate way that you've forgotten of all the steps that are involved in the process. Okay? So sometimes it's best to think of a real life example. Suppose I've got a pile of stuff on the floor, and I say, find the biggest of this pile of stuff. What's the first thing that you're going to do of all the stuff that's on the floor?
Go through it one by one.
Start out with the very first thing that you do, very first step.
Grab the first one.
Grab one thing. You pick up that thing, and what do you say to yourself?
This is the biggest one I have so far.
This is the biggest one I have so far. Okay? And so you've got this notion that in one hand you're going to hold up the biggest one that you've had that you found so far. Now that you've got one of them, what do?
pick up another one.
Pick up the second one.
Go through
The list, just
the rest, the remaining pile,
Compare each thing to what one you have.
You just rest.
and then what's the next step?
Compare.
Grab another one, decide which of those two is the biggest. So suppose I find the new one is the biggest, then what do?
You hold on to that one and toss the other one.
I transfer it and say, this is the biggest so far. Toss the other one of the two, so I'm always tossing one of the two, and then go back to the pile again. Okay? So part of this process, whether it be, pseudocode that they try to teach you to write or whatever, is just to try to get firmly in your mind exactly what you want to do and get those steps laid out. Because it's almost always bad to go and say, I'm just going to start doing stuff, because then you'll flail for a long time. Okay, so what was the first thing that we did?
Create a new variable.
What kind of thing were we going to go get?
For I in the list.
No, what was the very first step?
We were going to get a motor.
We grabbed a motor out of the pile of motors. Notice what happened there? That you were thinking, oh, I need the biggest number.
Get biggest so far.
But it's not the biggest number that's interesting. It's actually the biggest motor, because you're grabbing motors out of the pile. Okay? So if I start writing, it's not, biggest number, but it's biggest motor so far. Nothing wrong with using those words from your head. Okay? Where would you get it from?
List of motors.
The list of motors, which is all motors. So talk to the list and say, go get me, which motor should you get?
First one.
Any motor.
Any motor will do, but just to make our lives easier, might as well be the first one. And you're going to put that into what kind of variable?
A motor.
So there's the trick there. You're not bothering to record integers. You're going to keep track of which motor is the interesting one. Okay? So then what are you going to do?
Now you redo for each item.
You have to go through the rest of the motors.
Have to go through the rest of the motors. Now, if I write for motor in motor, another in all motors. What motor am I going to get first?
Biggest so far.
You could start with,
Exactly the same one all over again. Because 4H by definition goes through all of the ones in the pile, so I just got the first one out of the pile and I'm still going to go through and redo it. Okay? So one of the problems with 4H is that 4H by definition goes through all of them, and in this case we don't want to go through all of them, we want to go through one less than all of them because we've already got the first one.
unless you want it to be really thorough.
So a 4H probably isn't the best bet here. So we're stuck with writing a counted loop, and I'm just going to go back up and I'm going to steal the syntax for a counted loop. So it looks like that, and we'll put that in there and say maybe that's the best idea instead.
And you have to
But that one goes through all of them.
so change I to 1.
Then you start at the next one.
Okay, so this 0 is the first one that I would go get. Now I'm going to go get the number 1 motor as the starting point instead. Okay, so I just gave you this rule that said that 95% of the time you would write 0 to whatever. Well, there's the exception. And the exception is, well, if I've already gotten the first one, then I don't need to repeat it, so I can start at the second one, which is the number 1 motor. So anytime you see a 1 in there, you should see that somebody processed the 0, 1 immediately beforehand, which is why they're not doing the number 1. Okay? By the way, while we're on it, what about if I wrote that? What does that mean?
Meaning that we'll take the end of the list and -1.
So, I'm not going to do the last one. Okay? So it's the reverse. Those actually count the same number of times if you start at 0 and go to all but the last versus 1 and do the last one. They count the same number of items, and so people will sometimes, if they're counting, use them interchangeably, but they mean two different things, okay? So that says I'm not going to do the last one. I'm going to skip that one. This one says I'm going to skip the first one. Okay, so skip the first versus skip the last. So I'm going to go through all of the remaining motors, then what am I going to do? What's the next step?
If biggest so far does not equal, or no, sorry.
You have to get the number of hours from the motor that you're working.
I got the first one on the list. I'm going to go through the rest of the pile.
Compare.
Which one do I want next?
Sorry, it's bigger.
What's missing from this? What's the first line that you have to write?
You have to get the motor.
You have to go get the motor out of the pile.
Yeah.
Okay, so we'll have to talk to all motors dot get the next one out of the pile and put it into a variable. We'll call this one next one. And what type of thing is that? So it's a motor. Now what?
So now you have to compare them.
Now I have to compare them. What am I going to compare?
The number of hours each one has.
Number of hours each one has. So it wouldn't hurt to say hours on biggest so far is talk to biggest motor so far dot get hours of service. We can always shorten these variables later, so I'm just literally taking the words out of my head. So there's the hours on the biggest so far, and here's the, oops, I need a variable there, hours on next one, try to keep the wording the same, is talk to next one dot get hours of service, and then if
Hours on the next one.
hours on the next one, so it's, you say it just like you would say it in English, If hours on the next one, if I can find it, is more than hours on biggest so far, then what?
You're probably gonna wanna change that though.
Oh, wait.
You want to replace them, so biggest so far is the next one. We can do that to the biggest motor so far. And, oh, this is looking a little ugly, so I'm just going to use source format to make it a little prettier for me. And off we go. And then what?
Increment. Well, I guess it increments itself, yes.
But I is going to be done, so the only thing we've got left is and then we'll just print out biggest motor so far. Sure, print out the whole thing. Okay, a couple of things there. I could have written this the other way of the rejection thing. The reason I didn't, to break my own rule again, was because this is what you actually say in English. You say if the new one is bigger than the old one, then the new one is now the biggest one I've seen. So I wanted to write exactly what people would say, because there's that idea that greater than and saying what people will say is exactly right. By the way, some people will end up writing with this with a less than sign, and a less than sign is gonna, even though it may work, if you flip those around, it's not gonna give the sense of, oh, I'm looking for one that's bigger than what I have. So seeing that little greater than sign is important. And the other trick I pulled is that rather than getting all knotted up in how do I get those words inside an if statement, I extracted the values that I needed out where I could see them in the debugger. Now I've just got two really simple values to compare rather than having some complicated expression. So get the things you need step by step, and then off you go. Okay, so that does that thing. I'm just going to ask one interesting question here. This is the way that you'll see the code quite often. Who's doing all the work here? Is the class doing all the work, or is the main program doing all the work? Motor class doing the work, or the main program?
It's kind of half and half.
Who's fetching the values?
Classes.
Who's asking for them to be fetched?
The driver.
Who's doing the work of comparing to see whether or not one is bigger or smaller? The driver. So the driver is going and basically coming along and saying, I'm going to ask you a question, I'm going to ask you a question, I'm going to do the comparison. Is there an easier way to do that? A lazier way? With those two people, what's the lazy way for me to go see who's bigger?
Talk to one another.
Talk to him, say, see that person over there? Which one of you two is bigger? Notice what happened there? Management. I stopped caring about anything about the details of the thing. I just went, you people go to work and you come back, you come back and tell me whether you're bigger or she's bigger. I don't really care how you decide. First point, I'm not doing the work anymore, so this is a good thing. Second point, they get to figure out what bigger means, and I don't have to worry about it. Okay? So I always ask the same question. If it's two hockey players, I just go to one hockey player and I say, hey, there's another hockey player, tell me which one of you two is better. I don't have to worry whether that means goals, assists, points, plus, minus, what do you do if you're a goalie versus you're not? I don't care. It's just you two duke it out, come back and tell me who the winner is, and off I go. Okay? So I'm hiding the information by doing that. Okay? So what we're going to do tomorrow is we're going to go fix this thing by using that technique instead and pushing the work down a level into the class and letting the class figure out who's bigger. And I'm just going to go through all of the people and do the introductions and keep my hands off how the work is actually done.